Alright, in this video we are going to talk through measures of inscribed angles. We're going to derive a formula for the measure of an inscribed angle. So let's talk about first some vocabulary. An inscribed angle is an angle whose vertex is on a circle and whose sides contain the chords of a circle. So if we have the circle, here's the center. An inscribed angle is an angle whose vertex is on the circle. So we're going to put the vertex on the circle. And the sides of that angle contain chords of the circle. Remember, a chord just goes from one side to another. Here. So if we color code this, the sides are chords. So these guys are the sides of the angle. Okay, the vertex is right here. So the vertex is on the circle, and the inscribed angle would be that angle right there. That is your inscribed angle. Now, that's an inscribed angle. We've also talked about central angles. Remember, central angles have a vertex on the center. So this guy right here is a central angle. But this guy right here is an inscribed angle. All right. The arc that lies on the interior of an inscribed angle, so arc on the interior, here's the arc that's on the interior of the inscribed angle, and has endpoints on the angle, so there's endpoints are on the angle. It's called an intercepted arc. So we'll take a different color. This is the intercepted arc right here. Okay, so there's a little bit of vocab. So now what we want to talk about is what would be the measure of this angle. We talked about measures of central angles are equal to the measure of their intercepted arc. But the measure of inscribed angles are not necessarily equal to the measure of the intercepted arc, and we want to see how are they related. So let's now take a look. We have three different scenarios when we're talking about an inscribed angle. We could have an inscribed angle where one of the sides is the diameter, not just any chord, but actually a diameter, so going through the center. We also have where the center could be on the interior of the angle, or the center could be on the exterior of the angle. And we need to figure out what would be the measure of an inscribed angle for all three of these situations. So to do this, it says let x represent the measure of arc AC. So we're going to put an x here. That is. And then find the measure of an inscribed angle in terms of x by drawing in a radius or a diameter. So I'd like you, before you get started, or before you watch the videos, to try and figure out if you can figure out what the measure of angle ABC would be in terms of x, and you're gonna have to draw in a radius or diameter in order to help you. All right, so pause the video, try this on your own. Once you've tried it on your own, then continue watching. All right, so now that you tried it on your own, this is what I'm gonna do. I'm gonna draw in this radius right here, a radius ending at A. The reason that is helpful for me is if this is the measure of arc AC, then I know the measure of the central angle is x, because the measure of an arc is equal to the measure of its central angle. All right. I also know then that this angle must be a supplement, so that must be 180 minus x, because these are supplementary angles because that's the diameter. Something else I know is that these two sides of this triangle are congruent because the sides are radius, which means that these angles are also congruent. So I'm going to label that y here and y here. That means that y plus 180 minus x is equal to 180. Or if I subtract 180 from both sides and then combine like terms, 2y minus x is equal to 0, or y is equal to 1/2 of x. And in this situation, y represents the measure of angle ABC. So the measure of angle ABC is equal to 1/2 the measure of its intercepted arc. So that would be if one of the sides went through the center, or was a diameter. Now look at this situation. This one's going to be a little different. Here, the center is inside of the angle. So again, the measure of arc AC is going to be x. And we need to figure out what would be the measure of angle ABC in terms of x. And in this time, I'll give you a hint, you will want to draw in a diameter. So pause the video and try this on your own right now. Now that you have tried this on your own, I will talk through how I'm going to do this. So I will take this, I'm going to draw in a diameter here. The reason I did that is because in this previous problem, we know that if the side of the angle goes through the center, meaning the side of the angle is a diameter, we know how to find the measure of these angles. So let's see what that looks like. If this whole thing is x from here to here, I'm going to break this apart. I'm going to label this y. That would make this guy x minus y. Well, based on what we proved before, if this arc is y, then the measure of this inscribed angle, because the side goes through the diameter, is half of y. And same thing here. This would be half of x minus y. So when we look at this, the measure of angle ABC would be equal to 1/2 y plus 1/2 of x minus y. Using the angle addition postulate, this angle is made up of adding these two together. And now if we simplify this expression, this would be 1/2 y plus 1/2 x minus, if I distribute, 1/2 y. And now we have those two will add to be 0. And we see that the measure of angle ABC is equal to 1/2 x. So even if the center is in the interior of the angle, the measure of this inscribed angle is still 1/2 the measure of its intercepted arc. Now we have the last case scenario where the center is not on the interior of the angle. And again, my hint to you is you'll need to draw in a diameter and try to figure this one out as well. What would be the measure of angle ABC if the measure of arc AC is represented by x? Pause the video, try this on your own now. Now that you've tried this on your own, let's talk through how to do this. All right, there could be multiple ways, but how I would do it is to draw that in. Again, now that we've already done, if the inscribed angle has a side that's the diameter, or if the center is on the interior. So now if we do this, and then make this x, I'm going to make this guy y. Based on this first case scenario, I know that the measure of this angle right here, I'll have to draw in a little arrow, because that is the diameter, this would be 1/2 y, if that is y. Let's label this point D just so we have something to talk about. So we know that the measure of angle DBC is 1/2 y. It's half the measure of its intercepted arc. ABD is also an inscribed angle that has a side going through the center. So we know that that angle, measure of angle ABD, will be 1/2 the measure of its intercepted arc, which goes from A all the way to D, so we have to add x and y. So 1/2 the sum of x and y. And if we use angle addition postulate, I know that measure of angle ABC is just going to be ABD minus CBD. So measure of angle ABC is equal to measure of angle ABD minus the measure of angle DBC. And we have expressions for both of those angles. So measure of angle ABC is equal to 1/2 of the sum of x and y minus 1/2 y. And if I distribute, I get 1/2 x plus 1/2 y minus 1/2 y, which simplifies to the measure of angle ABC being 1/2 the measure of its intercepted arc. So we see no matter how the inscribed angle is drawn, whether the center is on the angle, is inside the angle, or is on the exterior of the angle, the measure of the inscribed angle is always equal to half the measure of the intercepted arc. What that looks like is this right here. So the measure of an inscribed angle, that guy right there, is 1/2 the measure of its intercepted arc. We also talked about the measure of an arc is equal to measure of its central angle, so we had that here as well. So this is our conclusion based on what we proved in the example above. And now what I'd like you to do is flip to the back, or to the next page rather, and use this information right here in order to solve these problems. So flip to the back, go ahead and work through examples 1 through 4, and check your answers with the answer key that is posted on the website to ensure that you guys are doing these problems correctly. Good luck.